Hello, sir.
Yes, welcome to E391, MM391. This is Engineering Economics. We are on week 13, lecture number 1. All right, there was one student who was just asking a question just before I began over here. Could you repeat your question, please? Somebody was saying something?
Yes, sir.
Yes,
So I
Amit.
just joined in the class. What were you saying about the exam?
Oh yeah, sorry. The tentative date. Let me copy and paste that. The short test is this Friday. That's confirmed. All right. That's this Friday, 19th November. Um, and the final exam, we are planning the final exam to be 8th December. It'll be online exam. All right, online exam. Not face-to-face exam. That's on 8th December. All right. That's the final exam for E391 as well as MM391. Same time, everybody will do the same paper and so forth. Okay. For your short test, my specific instruction is you will receive a question paper, and then everybody will receive the for a short test. Okay, Amit, you're asking for the final exam. For the final exam, we haven't finalized it yet, but you will have one whole day to do the paper. So it might be in two parts. It might be you spend 2 hours to do a small online exam on maintenance and reliability. Then you'll have a break, and then you'll do another short 1.5 hour online test to do engineering economics. Okay, all right. But it'll be all online, all based on Moodle. All right. At least I know for my part, it'll be all on Moodle. Well, even if it's not on, I mean, everything will be based on Moodle. Something similar to what you've done in semester one. All right. Okay. For your short test, guys, the duration of the portal will be available for 3 hours, from 9:30 in the morning till 12:30 midday. But within that 3 hours, you will have a 1 hour. That is the 3 hour window, or portal window will be open for 3 hours. Within that 3 hours, your short test is only 1 hour. Okay, your short test is only available for 1 hour. So yeah, so do not get the impression that your short test is available for 3 hours. It's only available for 1 hour. All right. Okay. And we will you will have to read the instructions carefully. I will be available from 9:30. I would encourage you guys to do your short test between 10 and 11, because I will be available on Zoom, and you can join in on Zoom and ask me a query. I won't give you the answer to the question, but if you have got some query with regard to some particular question, I'm ready to answer that. All right. Okay. Now the other particular point I want to mention about the short test is that the way it will be made is that we will have different we will try and generate different values for different students. All right. Okay. So you will need to quickly you will need to um, uh, you will need to look at the instructions very carefully. Okay. All right, guys. Let's now move to the lecture proper. I'm going to share the. I would like to share the the Word document. All right. I hope you can see the Word document.
Yes.
All right, thank you. All right, now, guys, I just want to mention over here. Last week we were doing a particular problem. We were doing a particular problem on interpolation. All right. Okay, so we started off with this particular problem number 7, with regard to payback period. The straightforward payback period problem is very easy, but then we moved on to part B, where we say, hey, a 5.5% loan was taken to do the payback period. So how do we calculate the payback period when it's a loan has been taken to how do we calculate the payback period when a loan has been taken to finance the particular operations? Well, the way it's done is basically you have to equate. We use P given A, right? We use P given A, and basically we want to find n, where n is the unknown. So let's make a table over here. I've showed you a side example of how we do the interpolation approach. Now let's look at this equation. So we were using P given A. If you remember from last week Friday, we were using P given A, and then we know our P, we know our A, we know our interest rate is 5.5%. Only thing unknown is n, but it's very hard to make n the subject of the formula in this particular scenario. So what do? Well, we basically we have to make a table. So let's go ahead and do this table. Um, um, we will fill up this table. Let's now find what is our P given our different values of n. So let me just stop sharing this particular Word document, and I would like to share my Microsoft Excel. All right, you probably can see my Microsoft Excel. Okay, so let's now try for different values of n. Can you see? Can you guys see my Microsoft Excel, guys? Can you confirm?
Yes, sir. Yeah.
Okay, now that's my different values of n, and this is my P. All right. Now let's now go ahead and calculate our thing. We have 7.52 million, 0.52 E6, right? Multiplied by. Let's now look at the numerator. The numerator is 1 plus 0.055 to the power of n, which is 4 over here, right? Okay. Maybe I need an additional bracket over there. We do a minus 1. Then you have a divide, open bracket, close bracket. We have 0.055 multiplied by open bracket, close bracket again, and it'll be 1.055 to the power of n. Okay, and we now pull that down. All right. Okay, and maybe I made that slightly larger. So we now realize, if you can see this, we now realize that our value sits somewhere between 4.25 and 5. Is that correct? Yeah, right. Because our target, what was our target? Let's write down our target. Our target is $65 million. Our target is $65 million. All right, so let's do another iteration. You have to do multiple iterations, at least 2 iterations, right? You have to do 2 iterations at least. Okay, now let's put the n and p over here. So we know that it's between these 2 values. We know somewhere between there. 65 million sits somewhere between there. So let's start off at 4.25. Then we do 4.3. And then we extrapolate till 4.5 because that's the value. Can you see this is the value which we originally had? Okay. Okay, and then we can copy the same formula. Okay, and we now extrapolate downwards. Let's see. Oh, we realize that it's somewhere between 4.25 and 4.3, right? So let's now go ahead and do this. .26, right? And there we are. Okay, and we finally settle for, we'll say that our value is between 4.26 and 4.27. We take 4.27. So our final answer is 4.27 years. So let's now stop sharing. So my final answer is this guy. Why? Because we now realize that our intercept happens somewhere between 4.26 and 4.27. We don't know exactly at what point. We can keep on going and doing this, and we will find a finer answer. But we can take even 4.26 as the answer as well. All right. So our final answer is, well, according to this, let me just get the Excel sheet. Well, the final answer right, let me stop the sharing and I will share the Microsoft Word document again. Okay, there we go. Can you guys see my Word document, guys? Hello? Can you see my Word document?
Yes.
Yes, yeah.
All right,
Yes.
okay. Okay, so your final answer, your payback period is equal to round about 4 point, you can put an approximate sign there, you know, is equal to approximately 4.26 years, right? So 4 years and a couple of months. Okay, and let's compare our answer. Let's compare our answer with our earlier approach. When there was no interest, the payback period was much faster. It was 3.71 years. All right. Oh, Tavake found the answer, 4.263 years. All right. So Tavake is saying 4.263 years. All right. Okay. All right. There we go. Okay. That's your answer. And guys, hey, if you don't want to use interpolation, if you want to use some other way to solve, let's say if you are good at MATLAB, and MATLAB might be able to use some kind of curve fitting or some optimization or something like that to solve for n, go ahead and do that. Our idea is that we want to find n, whichever way. So I'm just showing you one method which is used on paper. All right, if you don't have a calculator and if you don't have MATLAB. All right. Okay, guys, we are approaching the end of the course. Actually, let's move on to our next particular problem, whereby we want to find another particular type of problem called the internal rate of return. Right, another type of problem which is known as the internal rate of return, and basically that also requires us to do interpolation. Okay, so let's have a look at this question. Very simple question. Very simple question. It says, what is the IRR? What is the IRR of what is the IRR of a $1,000 investment that returns $200 at the end of each of next 6 years? Okay, that's a very interesting question, right? So we want to basically we want to find I. We want to find the value of I. So let's go ahead and do some drawing over here. There's no such thing as doing an engineering economics problem without doing the drawing, all right? Okay, so we have to almost certainly do the drawing. Okay, uh, let's go ahead and do the drawing. All right, so it's 6 years, not too long. Nice, 6 years. All right, 1, 2, 3, 4, 5, 6. Okay, I made a mistake with my drawing. All right, and basically it is saying, say 0, 1, 2, 3, 4, 5, 6. Okay, and we have, right, so we want to put a $1,000 investment down, right? We want to put a $1,000 investment, $1,000 investment, and then that investment will return, that investment is expected to return an annuity, an annuity of what is it, $200 per year. Okay, and that investment is supposed to return an annuity of $200 per year. Okay, sorry, 1 second. Okay, let me just clear my screen now. Okay, okay, now basically our I is unknown. Our I is unknown. How do we do this? Well, okay, let's go ahead. Let's see what sort of formula will we use over here, guys. Yeah, we can use either P given A or A given P, right? So we can use P given A. Let's try P given A. It's just sitting over here, so very easy for me to copy and paste. Okay, so we use P given A. Our P, okay, let's now just copy this again. Okay, what is our value of P, guys? Our value of P is 1000. Our value of A is known. It is $200. Our value of A is known, right? Yeah, okay, and the interest is unknown. The value of the time is known, 6. Okay, So one thing we can do is one easy way out is what I do is I usually um, what I usually do is um, rewrite this thing here. Basically, take the 200 on the other side, and basically that 1000 divided by 200 becomes 1000 divided by 200 becomes 5. Okay, all right. So that becomes 5. You see what I've done over here? All I've done is I've just taken the 200 divided on the other side, and that 1000 becomes 5. All right. So basically what that means, what is that trying to tell us over here? Basically what that's trying to tell us is that 5 is equal to P given A at, and look at the notation here. I want to show you the notation. I star. That is your estimated I, because usually I is given. We're supposed to find what is this. So we are trying to find I star. All right. So whereby we are trying to find your I star. All right. Okay, we are trying to find your I star. So how do we do this? Let's do a table. As usual, everything ends up with a table. All right, so this is our unknown. Our I star is unknown. Okay, so did you see what I did over here? That particular factor is basically P given A of n. Oh, sorry, maybe put a 6 over there. Yeah, put a 6. Okay. All right. Now, let's now do a particular table. And if you don't want to do the divide by 5, that's perfectly fine as well. That's perfectly fine as well. In fact, how about instead of bringing it here, how about I stop my screen share and I take you to Microsoft Excel? Okay, very easy to do it on Excel. And the good news is you guys have access to Excel. You guys have access to Excel. Wait a minute. There we go. All right, that was our previous problem. Guys, can you see my screen? Are you able to see my screen?
No, no.
Not yet.
No.
Okay, hang on a minute. Right, can you see my Microsoft Excel?
Yes.
Okay, nice. All right, so let's now just do the target, and we have, what was our formula? What were we looking at? Okay, even if we want to do, even if I want to do this guy here, that's perfectly fine as well. That's perfectly fine as well. All right. Okay. Okay, so our target is 1000, or if you want to make it 5, that's fine as well. All right. Okay, so we have your I on one side, and you have, what is this, P given A, right? P given A, and this is your P. All right. Okay. Let's see. Okay. All right. Now let's try different percentage rates. Let us try at because we're doing Excel, so we can go really fast. How about we do 5? Maybe we start off at 4.5%, and we do it iterations of 0.1%, and go all the way till 6%. Okay, so we can do it in much faster that way. Our P is equal to that'll be 200. What's the formula, guys? 200 times, let me see if I can pick up the same formula from here. There we are. Copy. Do you see when I'm flipping the sheets? Are you able to see when I'm flipping the sheets and all that kind of thing, guys? Okay. That will be 200. I is unknown at this time, but what we have to do, we have to do a divide by 100 over there, to the power of 6. We have to do a I divide by 100, and then that's 1 plus I divide by 100. Nope, that's not the answer. You have to do to the power of 6. Oh yeah, maybe I put a bracket around the I divide by 100.
So how did you use the MATLAB, like you said last time?
MATLAB? Yeah, you can use MATLAB as well. I'm just using Excel because easier to show you guys, and if you don't have MATLAB at home and all that kind of thing. But yeah, definitely MATLAB would be the superior way to solve this particular problem. All right, I'm just using Excel because everyone's got Excel, and even if you don't have Excel, you can use something like Google Sheets. There's a Google Docs and Google Sheets. All right, okay, so what we're finding over here, look at this. Our answer is sitting somewhere between 5.4 and 5.5%. All right, so let's now copy this. Let's now bring it here. All right. And also, some of the mechanical engineers may not be too confident about MATLAB, but hey, it's a very important thing to do. All right. Very important piece of software to learn. Both Excel is very important. Do not underestimate Excel. And MATLAB is also very important. Okay, there we go, guys. Can you see the closest answer is either 5.47%? So that's our answer. So our answer is 5.47%. All right, that's your answer, guys. 5.47%. So that's how we did it. Let me just copy this thing here onto my Word document. All right, there we go. So our final answer is I star is equal to I star is equal to 5.47%. There you go. That's how you'll do it. Okay, let's now have a look at the next particular concept. So that's what you call an incremental rate of return. So, if you look at everything, we've been solving for annuity, we've been solving for present value, we've been solving for future value, we've been solving for gradient, present worth, annual worth. This is now finding the rate of return. So this is actually one of the most useful ones, because when you buy a machine, your boss will ask you, what is the rate of return? What is the rate of return on so and so machine? So then you'll have to calculate the rate of return. And I'm showing you interpolation. It's not absolutely necessary for you to use interpolation. If you want to go ahead and use something like MATLAB and use the solve function, or one of the optimization functions, or something like that, particle search, particle swarm, or something like that, that's fine. You can use it as well. There's no problem. It'll give you the same answer. It might even give you an answer which is further, fewer, more more decimal points, but I usually stop at 2 decimal points. All right, guys. Okay, and because we're using Excel, it's much faster. If it was a paper examination whereby you don't have access to any tools, then I would say, oh, stop at 1 decimal point. That's what I usually do. But because we're using Excel, 2 decimal points is reasonable to ask. All right. Okay, let's have a look at this next question, guys. We have to use incremental rate of return to select the best option from problem 6. All right, let's now copy problem 6. Let's go back and copy problem 6. Problem 6 was about 3 lathes. Okay, that was problem 6, all right? So that we don't have to go back and forth. Okay. This will be a long question, but you know, it's very useful because this is what your engineering industry guys will ask you. In fact, there's lots of other forms of analysis, but because of our time constraint, we only given, in fact, effectively 7 weeks to teach, and I want to finish most of our lectures this week so that you have a bit of revision next week. 8th December is your final exam, and also I understand that next week you will be doing your EE399, MM391 is next week, so a lot of you students will be fully loaded, so that's why I want to clear off as much as possible this week, and next week will be only revision and so forth. And we might cover one more topic, which is called bonds, how a government used bonds to pay for a bridge. In fact, Fiji used bought bonds to pay for the Suvarnasori corridor and all that. All right, let's now do this particular calculation. Problem number 9. So we're going to only look at lathe 1, lathe 2, and lathe 3. All right, so let's now look at lathe 1. Let's see if I can pick off from here. Okay, lathe 1. All right, lathe 1. Let me just color that red and underline that. Okay, and we will clear. Okay, for lathe 1, forget about this part of the question, guys. We only are interested in we're only interested in finding the rate of return from lathe 1. So what I'll do is I'll crop, because you guys might get confused with looking at all the other MARR and all that, right? So that's the lathe over here. All right, now that's a much neater problem. Okay, all right, there we go. That's the only information we need. All right, so what sort of thing can we use over here to find the annual rate of return? Again, I think it's a P given A sort of problem, right? Okay, so let's do a P given A, and our P given A is here. Okay, so for lathe 1, our P given A, we use P given A. Our P is what? What is our P? That's 100,000. And what is our A? Our A is 25,000. And our N. Oh, what was our N, guys? Did we note what the N was? Let's go back to problem number 6. What was our N over here? 10 years. 10 years. All right, 10 years. Our N was 10 years. Let me just put that down. Useful life is equal to 10 years. Okay. All right. Okay. So 10 years. What do we get? What do we get over here? Let's rub this off. we can say 4, you know, we can say 4, we can do a 10. So either you can put the big numbers in, or either way you will find some answer, right? Okay, and we've got to find our I star. We've got to find our I star. All right. Okay. Now our I star. Let's now switch over to Excel. Can you guys see my Excel, guys? Can you see my Excel? Hello?
Yes.
You can see my Excel, right? Okay, lathe 1. Lathe 1. Let me just copy from the Word document. This is the equation. So we want different values of L, and our target is basically 4, and this is our formula. This is our formula. That's our target, right? And then let's start off with, we have to start off with some number, right? And because you're using thing, let's start off at let us say let's go between 5. Let's go between 5 and 6%. In fact, the first step, what you do is you usually go big numbers. Okay, let's go between 5 and 10%, and then we'll see what the difference is. So 5 and 10%. 5. All right, let's just copy the formula from here. Copy. All right, and we don't need the 200 no more. Okay, and our A5 is that, and that should be at 10. That should be at 10. Okay. All right. Now, guys, our target was the number 4. Can you see this? Our target was 4. 4 should equal to this factor over here. All right. And when we placed interest rate of 5 and when we placed an interest rate of between 5 and 10%, there was nowhere near 4, but it was approaching 4. So what we do is we can, because we're using Excel, it's so easy, we can go till 15 and let's see what happens. Still, we have not achieved our target. Let's go all the way. Let's go all out till 25. All right. Okay. So can we see, finally, it's somewhere between 20 and 21%. Somewhere between 20 and 21%. All right. Okay. And our target should equal to 4. Right, so obviously if it's between 20 and 21%, let's now make it an iteration of 0.1. Okay. And we realize that it is the target of 4 is actually happening somewhere above 21%. Hang on. So let's now make it, maybe we made a mistake. If you look at it properly, if you look at this zoom in properly, it's between 21 and 22. Tavaki, you're correct. Yes. So let's now correct that. 21.1. All right. I didn't realize, guys. I'm looking at the screen, so I'm not necessarily looking at the chats. All right. So if any mistake I make sure you call it out straight away. All right. So we realize it's between 21.3 and 21.4. All right. So it's between 21.3 and 21.4. In fact, we can say 21.4 because it's 4.000, we may as well accept that it's 21.4 because that's to 3 decimal places. That is the correct answer. Somebody is saying something. Can you repeat your question, please?
So it was between 21.4 and 21.5.
Yeah, 21.4 and 21.5. Yes, you are correct. It was between 21.4 and 21.5. Yeah, that's correct. But because if you look at the 21.4 answer, it's 4.000. That's to 4 decimal places. It's very close. So we don't need to do further iteration. When you find an answer which is almost double zeros over there, we know that our answer is correct. Okay. So let me just copy and paste this thing here. We are using Microsoft Excel, but if you want to use something else, that's fine as well. All right, that's fine as well. Yeah. Okay, there we go. So your final answer, our I star is 21.4%. Okay, 21.4%. Right. That's not the end of the question, guys. That's not, certainly not the end of the question. Let's now have a look at lathe number 2, right? There's some more calculations to be done. It's not just a matter of just substituting and doing this thing here. Okay, let's now have a look at lathe number 2. Now with lathe number 2, the formulas of course stay the same. And that's the lucky thing about for you guys. The formulas stay the same. Lathe number 2, 150 and 34. All right. Okay. 150K and 34K. Because I want you to note this particular concept over here. Notice the word incremental RR. Incremental IRR. In problem 8, what were we doing? We were just doing IRR. Internal rate of return, or internal rate of return. Okay, IRR. But what does question 9 ask us? Problem number 9 is asking us for incremental. That's the key word over here. They want us to do incremental, which is slightly different. So that's what I want to show you. That's exactly what I want to show you today, is this concept of incremental rate of return. Okay, so all that stays the same. 150 divided by 34 gives us, what does it give us, guys? $150 divided by 34. No, because the K's are already divided, so you will get 4.11. Yeah, 4.412. Right. All right. So basically the same thing. Let's go to Excel once more. Let's go to Excel once more. Okay, I'm going to copy this over. Lathe 2. Okay, and we have all right. This is the catch now, guys. This is the catch. In incremental, maybe I should go back to the Word document before I come over here. In incremental IRR, what we usually do is we have to compare against the previous contender, if you could say that. All right, we have to compare against the previous contender. All right, what was the previous contender? The previous contender had a p-value of 100,000. So we have to do a subtraction here. All right, we want to compare against our previous contender. Right, so that's 34,000 minus 25,000. All right, where did we get these values from? Where did we get the 100,000 and where did we get the 34,000? Well, the 100,000 comes from lathe number 1 and the 24,000 was the annuity from lathe number 1. Right? So this answer is actually a bit wrong. So in fact, what we get is 150 minus 100,000 gives you 50,000. Sorry. Gives you 50,000. 24,000 minus 34,000 minus 25,000 gives you 9,000. Right? Okay. So therefore, and what is the reason? What is the reason we have this? Well, the reason is you want to do a side-by-side comparison to the previous contender. Sometimes in the real environment, in the real workplace, you don't have an opportunity to compare one particular machine with another machine, like comparing two quotations, but rather to compare the current machine with the next one up, right? And I'll show you some further particular points. All right. Okay. Now that is 50,000. So what we get is we have, if we now further reduce that, we are able to say that that is, and I think Amit is saying it's 5.56. 5.56. All right. Okay. Now, given that that is 5.56, 50 divided by 9 is equals to 5.56. 50 divided by 9 equals to 5.56. All right. We want to find I star. All right. Let's now go and find I star. I'm going to copy that.
So where do we get the 5.56?
Oh, Guy, my friend, what we do is 50k. When you bring this 9k, can you see my circle over here? You take this 9k onto the other side. You divide 50,000 divided by 9,000. You get 5.56. Is that clear?
Okay.
Yeah.
Yes.
All right. Okay. Nice. Okay. Now, our target now is 5.56. Right, and let's start off at 4%. I think, yeah, that's all seems to be okay. Yeah, so we can recycle that formula. Let's now do iterations of 0.1. In fact, the first time around, you should do just 2 or 3 and then see how far it goes. Oh, look, we haven't reached 5.56, so we'll have to take this further down. Wow, still not yet. All right, it's between 12 and 13%, it seems. Is that correct? Yeah, between 12 and 13%. Okay. Why do we minus P and A from the previous lathe? Yes. Okay, guy. Tabake, thank you for the question. The reason why we subtract, let's come here. The reason why we are doing a subtraction is because this is not our IRR. See, in problem number 8, we were just doing an internal rate of return. In problem number 9, we are doing incremental rate of return. So when we do incremental, this is slightly different. You have to compare by subtracting, all right? Now, subtracting from the alternative. You have to compare by subtracting from the alternative. Okay? Okay, but still, that won't give you the final answer. Okay, lathe number 2. So we know that it's between 12 and 13%. Alright, so what we can do is we can now put it at 0.1 iteration. And for today, let's just try and do at 0.1 iteration. What do we get? Where does it hit? 5.56. Where does it hit 5.56? 5.56, 5.56. Somewhere between 12.3 and 12.4, yeah? Is that correct? Between 12.3 and 12.4? Alright, so let us say that our answer is 12.4. Right? Okay, now let's come back to our Word document. So our I star for this particular case is equals to 12.4%. Fine. Now, remember, what was the MARR for this particular problem? I sort of rubbed it off. I should have left it there. The MARR is equal to, let's look at the original question. It was 15%. Yeah? 15%. So let's come down here. I want to note that down. Your MARR is equals to 15%. Okay, now lathe number 1 is the original lathe. Your MARR is 15%. Now you want to achieve something which is above or very close to 15%, right? So lathe number 2 looks promising, but not the final answer. Let's now look at lathe number 3. In fact, I forgot to copy and paste the Excel sheet over here. Okay, there we go. Okay, right, let's look at lathe number 3, guys. In lathe number 3, this is the catch now. This is where it all plays a part. Right, lathe number 3, and we are down to a few minutes. Lathe number 3, we're going to do, in lathe number 3, the question says 200,000 and 46,000. We have to do 200,000 minus the base one, minus the base value. All right, so 200,000 minus the base value, right? So it'll be 46,000 minus 25,000. Can you see, we are comparing, when we do incremental IRR, we are comparing against a base value, all right? And the base value in this case is our lathe number 1. 46 minus 25 gives us what? 21,000. And yeah, Amit is saying that is 4.76. And then we have to do a 4.76 over here, and we have to again go back to Excel. And guys, I think we have sort of run out of time. We will be finishing off this problem at 1 o'clock tomorrow afternoon, and tomorrow we'll be discussing about our short test. All right. Okay, but we still have to find this, and maybe you guys can go and attempt it. You guys can go and attempt this particular problem on the. You can attempt this particular problem with Excel, and we'll get back to you tomorrow. All right. Thank you for attending this afternoon. We're out of time now, and we'll see you tomorrow, Tuesday at 1 o'clock. Thank you so much for attending. Goodbye.